far beyond Neptune, beyond Pluto, beyond the Kuiper Belt, and far beyond anything a spacecraft has ever crossed. Astronomers believe the solar system fades into a vast invisible reservoir of ice. This region is called the Oort Cloud. It has never been photographed directly, and no telescope has clearly resolved its individual objects as a population. Yet it may contain billions, possibly trillions, of frozen planetesimals orbiting the Sun at extreme distances. The idea sounds almost mythical, a hidden shell around the solar system, so distant that its outer edge may reach a few light-years from the Sun. But the Oort Cloud is not just a speculative decoration on astronomy diagrams. It was proposed to solve a real problem: where do long-period comets keep coming from? To understand why the Oort Cloud was proposed, start with comets. A comet that dives near the Sun does not last forever. Each close pass heats its frozen surface, releases gas and dust, and strips away material. Over many returns, comets can fragment, fade, or be destroyed completely. So if long-period comets have been visiting the inner solar system for billions of years, there must be a source that keeps replenishing them. In 1950, Dutch astronomer Jan Oort studied the orbits of these distant visitors and suggested that they come from an enormous cloud of icy bodies surrounding the Sun. His reasoning was indirect but powerful: the comets we see are the visible evidence of a much larger hidden population. The distances involved are difficult to picture. Earth orbits the Sun at 1 astronomical unit, or AU. Neptune is about 30 AU away. The Kuiper Belt, home to many icy objects beyond Neptune, extends roughly tens of AU from the Sun. The Oort Cloud begins much farther out, perhaps around 2000 AU, and may stretch to around 200,000 AU. That is about 0.03 to 3.2 light-years. At those scales, the Sun is still the central gravitational anchor, but its grip is weak. Objects there move slowly, faintly, and at such enormous distances that present-day imaging technology cannot easily detect them directly. The Oort Cloud is therefore known mainly through orbital clues left by comets. Astronomers usually describe the Oort Cloud as having two main parts. The inner region is often called the Hills Cloud. It may be more disc-shaped and roughly aligned with the plane of the solar system, the same broad plane where the planets orbit. Outside that lies the outer Oort Cloud, imagined as a vast spherical shell surrounding the solar system in every direction. This distinction matters because the two regions may behave differently. The inner Oort Cloud could be more tightly connected to the original architecture of the solar system, while the outer cloud is more exposed to outside gravitational influences. Together, they form a distant storage zone for icy bodies that were pushed outward long ago. The Oort Cloud is not thought to have formed where it is today. Most models suggest its objects were born much closer to the Sun, inside the young protoplanetary disk where planets and smaller icy bodies were forming. During the solar system's early chaos, the giant planets, especially Jupiter and Saturn, acted like gravitational slingshots. As smaller bodies passed near them, many were scattered outward onto huge orbits. Some were ejected entirely into interstellar space. Others remained weakly bound to the Sun and gradually settled into the distant reservoir we now call the Oort Cloud. In this sense, the cloud may be a fossil record of the solar system's violent youth. Once icy bodies were thrown to great distances, the galaxy itself began to matter. Near the planets, the Sun dominates motion almost completely. But in the outer Oort Cloud, the Sun's gravity is faint enough that passing stars, giant molecular clouds, and the overall gravitational field of the Milky Way can reshape orbits over long timescales. These outside forces can make extremely stretched orbits more rounded, helping populate a broad spherical cloud. They can also do the opposite. Disturb an object just enough to send it falling inward. After millions of quiet years, a small gravitational nudge can turn a frozen body at the edge of the solar system into a comet headed toward the Sun. This is why long-period comets are so important. Unlike short-period comets, which return on timescales of decades or centuries, long-period comets can take thousands, millions, or even longer to complete one orbit. Some appear from directions that do not line up neatly with the flat plane of the planets. That pattern makes sense if they originate from a distant spherical cloud rather than a flat disk. When one of these comets enters the inner solar system, it carries clues about deep time and distant space. Its orbit tells astronomers that it may have spent most of its existence in darkness, barely warmed by sunlight, until gravity redirected it inward. The Oort cloud is also connected to the boundary of the solar system, but not in the simple way people often imagine. The planets do not end and then suddenly space becomes interstellar. Instead, there are several boundaries depending on what you measure. The heliosphere is the bubble created by the solar wind, and spacecraft like Voyager have crossed into interstellar space in that plasma sense. But the Oort cloud lies far beyond the heliosphere. Gravitationally, however, the Sun may still hold many of these distant icy objects. The outer Oort cloud therefore sits near the fuzzy frontier between the Sun's domain and the wider galaxy's gravitational influence. The outer limit of the Oort cloud is often linked to the Sun's Hill sphere. This is the region where the Sun's gravity can hold objects against the competing pull of the Milky Way and neighboring stars. Near the outer edge, the balance becomes delicate. An object may remain loosely attached to the solar system for ages, but a passing star could perturb it, remove it, or send it inward. This makes the Oort cloud less like a solid wall and more like a gravitational atmosphere. It gradually thins into interstellar space. The solar system, seen this way, is not a neat collection ending at Pluto. It is a vast gravitational structure with a distant, fragile halo. Not every comet has the same origin story. Many short-period comets, especially Jupiter family comets, are commonly associated with nearer reservoirs such as the Kuiper belt and scattered disk. But some short-period comets, including Halley-type comets, may be linked to the Oort cloud or its inner disk-like component. The difference comes down to orbital shape, inclination, and how gravitational encounters with planets have changed their paths over time. A comet's current orbit may not perfectly reveal where it first came from, because Jupiter and other planets can reshape comet trajectories. Still, the broad pattern points to the Oort cloud as a major source for long-period and some intermediate comet families. Because the Oort cloud cannot yet be observed directly, scientists build the case for it through models, comet statistics, and gravitational reasoning. They ask how many comets should exist, how often they should enter the inner solar system, and what kind of distant population would maintain the supply. They also simulate the early solar system to see whether giant planets could scatter enough icy bodies outward. The answer is that an Oort-like reservoir is not only plausible, but useful for explaining what we observe. Still, there are uncertainties. Its exact mass, object count, structure, and outer boundary remain open questions. The Oort cloud is one of astronomy's best examples of an unseen structure inferred from motion. The Oort cloud changes how we think about home. The familiar solar system of 8 planets is only the bright inner core. Beyond it may lie an immense, dark archive of ancient ice, preserving material from the time when the planets were forming. Occasionally, gravity selects one of those bodies and sends it sunward, where it becomes visible as a comet with a glowing coma and tail. For a brief moment, something from the remote edge of the Sun's influence enters the human sky. That is the power of the Oort cloud idea. It connects a streak of light near Earth to a hidden frontier measured in light years, where the solar system slowly gives way to the galaxy. If you found this helpful, please like this video and subscribe for more explainers.